This vodcast is a subunit of a much larger one about Year 8 physics. Whenever we have an object falling, it converts the gravitational potential energy into kinetic energy. And we're going to discuss a trolley on a roller coaster. The trolley is 400 kilograms in mass, and it's 100 meters off the ground. So at point A, it only has gravitational potential energy. And to work out that GPE, the equation is mgh. So if we put in the values, GPE equals 400 kilograms times 9.8 meters per second for gravity times 100 meters, which is the height, and it equals 392,000 joules. As the cart starts to move, the energy in the gravitational potential energy is transferred into kinetic energy. At point B, which is only 50 meters high, half of the GPE has been converted into kinetic energy. So we still have half the energy as gravitational potential energy at 196,000 joules, and the other half has been converted into kinetic energy, which again is 196,000 joules. And as the cart goes away from B and falls down the last bit of the hill to C, all of the GPE has been converted into KE. So the kinetic energy is 392,000 joules. Now to work out the velocity of the cart at C, we need to transpose the equation for kinetic energy. So remember KE equals a half mv squared. We need to isolate V. So if we go through the steps, because it was divided by 2, it's now times by 2. So it's 2KE equals mv squared. Then we need to move the mass, so it becomes V squared is 2KE on M. And now we need to get rid of the squaring, so V equals the square root of 2KE on M. And if we work through this equation, we find that V is 44 meters per second.